Athletics has changed. It's become increasingly global, often requiring extensive travel at the highest level. Take UCLA moving to the Big Ten Conference. The football team alone is expected to travel 22,226 miles this season. While this might provide UCLA with better competition and more revenues, it overlooks the important costs for students. This travel comes with frequent time changes, the need to adjust to new environments, and additional stress. All of these can disrupt the individual circadian rhythms that keep us healthy and sharp. To better understand what circadian rhythms mean to athletes, I interviewed Dr. Allison Brager. She's a neurobiologist that specializes in circadian rhythms, sleep, and behavioral genetics research. She is currently the Deputy Chief Science Officer at the JFK Special Warfare Center and School, leading the Special Forces research into human performance. Dr. Brager is also an elite athlete herself. She was a professional CrossFit team athlete and an 11 times Gay Games gold medalist. Allison served on the NCAA Task Force for Mental Health and Sleep and was a contributor to the NCAA Student Athlete Mental Health Handbook. She's also the author of Meathead, Unraveling the Athletic Brain. In this episode, we touch on the purpose that the circadian rhythm serves, the things that can disrupt it, and how we can help to regulate it during travel and stressful situations. We also touch on how Dr. Brager turns her research into practice in her athletic pursuits. Dr. Allison Brager, thank you so much for coming on the Exponential Athlete Podcast. Welcome.
Yeah, it's great to be here. Thanks for coming to our facility. We can't wait to open it. It's truly one of the largest in the country, and we can't wait to have all of our students come here through it.
So for those that don't know, we are at Fort Liberty in the HP Forge, the Human Performance Forge. This is a brand new state-of-the-art facility. Allison was wonderful enough to bring me in, show me around, and I get a little behind-the-scenes look on all of the incredible human performance stuff you're doing here. This is super surreal for me.
Yeah, here in the gym, and then you went out to the field this morning. So you got the real hua Army experience for sure.
Absolutely. And I was pleasantly surprised at how everything's structured, how innovative you guys are with the technology, but also how you're able to kind of isolate them, right? So the idea is that you can be unbelievably data driven, but you can also sort of step away and have the soldiers actually focus on something and not be distracted by all these things ticking on them and keeping all their information, which is very cool.
I mean, that's really the method behind the madness in terms of assessment and selection. But it also speaks to the number one special forces truth is humans are more important than hardware. Yes, when it comes to hardware, science, we move at the speed of relevance, and we are truly the tip of the spear, like we like to think of ourselves. But when it comes to the human, we always put the human first.
And that's one of the reasons why I'm really excited to interview you is you obviously have this incredible background in biorhythms and in sleep and in behavioral genetics, but you're also an extremely high level athlete. You're also, you've been in the military for a long time. You have this very well-rounded knowledge where you've seen human performance from a bunch of different lenses. And it's exciting to talk to you who's able to kind of consolidate those together in a really elegant way. So
no, absolutely. I think one of the things my coaches always used to tell me in high school was to always plan your career around your lifestyle and not your lifestyle around your career. And really, I felt once I commissioned in the Army, I was able to fully do that and still embrace those identities of being an athlete, being a scholar, and being someone who does hard things daily.
I love that. And so, kind of tying this all together, obviously my last guest was Dr. Grandner.
My buddy.
We talked a ton about sleep. He actually introed me to you. And we're coming off a great conversation around sleep. But something that I think kind of precedes sleep is circadian rhythms, right? Sleep is maybe a function of circadian rhythms in some sense.
Yeah.
And I'd love to get your perspective. This is obviously an area you researched very, very heavily about what are the implications associated with that for sports. And maybe we could just start off with describing what at a high level circadian rhythms are and then go from there.
Sure, absolutely. And I think we talked about this. It's funny that we're doing this interview today because just today, the New York Times article came out that I was quoted and interviewed for to look at the consequences of the Big Ten and the Pac-12 joining forces and what impact that will have on student academic and athletic performance. But I do agree, you are right. I come from that camp of research and that sleep is a byproduct of circadian rhythms. So I actually was a classics major in college. I majored in Latin and translating a dead language. And one of the things we know about circadian rhythms is circa means around in Latin and dia means day in Latin. So that's essentially what a circadian rhythm is. It is a rhythm that operates in about a 24-hour period. Now, we know from a lot of research done under constant routine and constant conditions in the lab, and believe it or not, one of the first circadian rhythms experiments in humans was done in Mammoth Caves, Kentucky, where I actually had my promotion ceremony from captain to major because I was stationed at the time at Fort Knox, Kentucky. We know from that research that the average circadian rhythm for a human is a little bit longer than 24 hours. Now, that's not true for every species on the planet. In graduate school, I worked a lot on mice, rat, hamster models of circadian rhythms. They have a shorter clock than 24 hours, but through us and human evolution, our clock is longer than 24 hours, which is actually part of the reason why it's easier to stay up late than to go to bed early, and why for a lot of people, it's easier to travel from east to west rather than west to east, which honestly today I feel like I'm still suffering from because I was out on the West Coast last week for work.
That makes a tremendous amount of sense. And something I think is interesting as well, and is that it's not just sleep and wake cycles. Like within the wake cycle, within the sleep cycle, there's also different ebbs and flows as well. I was wondering if you could talk maybe about, particularly in the wake cycle, what are some of the implications of early in the cycle and later in the cycle?
So the big one, one we care about here, especially, is testosterone. Testosterone and cortisol. Those, when it comes to performance enhancement in sports and high levels of human performance, that's what you care about. Testosterone for recovery, and that's true for both men and women. Men and women both secrete testosterone, and cortisol, because that's what's going to drive the production and release of all the energy reserves that are required for high-level cognitive thinking, as well as complex, intense physical activity. So what we know is testosterone is highest in the morning because it's secreted at night. So when you wake up in the morning, your testosterone is high and your cortisol is low. But as you go throughout the day, your cortisol levels rise. And then as the day dips down, your cortisol decreases. Now, when it comes to athletic performance, we also know because of that, because of this robust circadian rhythm in cortisol, for example, that's tied to specific types of athletic performance or high-level peak performance at different times of the day. Most often, when it comes to highly complex cognitive tasks or fine motor movements, that's going to be primed and prioritized between 10 a.m. and noon as the cortisol is rising. And one of the things we actually find really interesting about sports is weightlifters, for example. They've done studies in powerlifters. They've done studies in people who do Olympic weightlifting, that people who lift in the early evening perform better than the early morning because of other factors related to cortisol, such as norepinephrine and epinephrine. Those two systems are primed in the evening. So it is really unique how you can take somebody's circadian rhythm and tailor their circadian rhythm to when they're going to peak in a particular athletic task or even cognitive tasks.
So are some athletes, for example, let's say you play in the NBA and all your games are at night, but your practices very likely are not often at night. I assume there's some implications of that on how they might perform in the game versus in practice, things along those lines.
Yeah. So actually, I do believe a lot of teams now, because circadian rhythms and knowledge and basic foundations of sleep have been well applied to sports now. I know, my buddy Michael Granier, he does that. I've done a little bit of consulting with professional Olympic teams over the years in that area. They're now shifting their practice schedule to when their games are projected to be. Because one of the things we know about circadian rhythms is they're these also entrainable oscillators, as they're called. We have food entrainable oscillators. We have reward-seeking entrainable oscillators. So the more that you can program your peak activity around certain times of day, your body's going to shift its physiology and shift its behavior towards peaking at that time of day. And so you're better off practicing at night if you know your games are going to be at night.
So you said it was a trainable oscillator. Is that correct? That's effectively things that can move your circadian rhythm.
Yes, correct.
Okay.
Yeah. So what's unique about the circadian clock is the epicenter of circadian rhythms is in an area of the brain called the suprachiasmatic nucleus. It lies at the base of the brain where the two retinal stalks cross, the optic nerves, and it's about the size of a grape. But there's all these other brain areas that have additional oscillators that feed back onto this suprachiasmatic nucleus. And that's where we know this food entrainable oscillator is, this reward-seeking oscillator. So it is, believe it or not, a very complex system as well. And it's not localized to just this nucleus or the hypothalamus of the brain. It's other areas of the brain as well. So without getting too deep in the weeds.
I think this is the perfect level of deepness.
Okay.
So I'm interested within that vein of thought. If we have these rhythms, how much do they vary by individual person? When we hear about sleep chronotypes and things along those lines, is that related to circadian rhythm at all? Or like, what is the relationship?
Oh, absolutely. So I've coached track and field for a very long time. Ever since I gave up on my Olympic journey to be an Olympic athlete, I started coaching high school level, college level. I still coach today at a pole vault facility up near Duke. And that's actually one of the things I give my athletes now. It's a clinically validated questionnaire. It's called the morning eveningness questionnaire. And it's a tool we use in a clinical sleep setting to identify if you're a morning person, an evening person, or somewhere in the middle. Now, it turns out that 80% of the population are neither. So they're neither morning, they're neither evening. But one of the things I find really fascinating is athletes like myself, true evening people. Makes sense. I was a dancer and a gymnast my whole life. So I didn't go to dance practice until 5 p.m. and I didn't come home from dance and gymnastics practice until 9 p.m. Genetically, my parents are also night owls, and that influences a lot in terms of if you're an evening or a morning person. And I'm so nerdy that I even used 23andMe to get, my DNA sequenced. And sure enough, I have the unique polymorphism associated with being an evening type. So how that relates to sports is there actually was a study that was done, I believe it was a rugby team in the UK, where they found you want people who have a lot of variability in performance. Because if you are, say, an NFL team, not all your games are going to be evening. Some are going to be afternoon. And in fact, some of them may be morning in your home team time, right? Because they don't have enough time to adjust to new time zones. So you kind of want variability in people who are morning types, evening types, or, somewhere in the middle. And that's actually what this study found is people who had variability in this chronotype of being a morning or evening person or neither, they were more likely to win games than people who had more evening types or people who had more morning types. Now, the exception to that would definitely be sports like hockey and basketball, right? Because those are all evening games.
So something I really want to make sure I do is I'm going to put the link to the article you were in as well as that diagnostic for chronotype in the description,
sure.
Just to make sure people have that as a resource. Because to me, that's something that is very actionable from a coaching perspective. If you're working with elite athletes, especially individual athletes, where you don't get sort of the diversification of having all the different chronotypes on a team, is that you might have someone coming in for 7:30 a.m. practices every morning because, hey, it builds discipline, it does all this stuff, but might not be how you get the most out of them. It might not be how they function. I know a lot of school districts, things along those lines, especially when you're younger, if I remember correctly, you need more sleep.
Yeah.
Is it also true that your maybe circadian clock is also shifted a little bit when you're younger?
Yeah.
Okay.
So actually the woman I worked for, Dr. Mary Carskadden, I was an undergraduate research assistant in her lab at Brown University. That is her claim to fame. Personally, I think she should have got the Nobel Prize in Physiology and Medicine that year that the circadian biologist won. She was actually nominated for it because her research in that area of how the circadian clock delays itself naturally with puberty truly changed public health. So her research that I was fortunate enough to work on is the reason why a lot of school districts now have delayed their school start times for high schools. And those delayed school start times are linked to better academic performance.
I wish they had moved my back.
Oh, same here.
So
I mean, my high school, I think it started at like 7:45, which honestly I heard was like not too bad. But, me being already an evening person, that was still pretty rough. I mean, I joke and this is true. Like, I am not a morning person. And like, even if I wanted to be a general, I don't think I physically could make it because my clock fights against me. When I was in company command, the only time I had to work out in the morning was with my brigade commander at 5 a.m. And during that time, while I did it, I got sick pretty often. Even if I try to get enough sleep, if I try to eat healthy, if I try to do everything else right, I found myself breaking down because I was fighting against my natural biology. But if you want me for a night mission or to stay up really late, I am your person. So I really think, to bring it back to the military, chronotype has a huge implication and importance for us too. And I do think people truly select into certain positions in the military because of these chronotypes and because of, something we were talking about yesterday with genetics, whether people want to admit it for better or for worse.
So I think actually towing into that genetics conversation, something my neurochemistry biology is a little rusty, but if I remember correctly, I think it's cortisol, first release of that in the morning is something that stirs awakeness.
Mm-hmm. Absolutely.
Cortisol is also a stress hormone.
Yep.
So I would imagine that there's impacts on the circadian rhythm associated with stress. Can you talk a little bit about that?
Yeah, absolutely. So it's all about what activity you're doing at the time as cortisol is rising. So for example, I oftentimes get anxious mid-morning and it's something I can't control. Like I can take out that anxiety through working out and being physically active, which makes sense, right? Because physical activity is peaking during that time. But if I'm doing anything that requires me to like really sit still, like I feel anxious. While I can be focused and be attentive, I don't feel comfortable in my own skin. And I really think that's because your activity is fighting against what hormonally and physiologically your body is doing. Another example, right? In the middle of the late evening, you get that dip in energy, especially after dinner. And then for a lot of people, it's because your core body temperature is decreasing to sort of prepare yourself for sleep. But then what happens? We do an activity and then our core body temperature starts rising. And then we go from this state of sleepiness to a state of high alertness and get that second wind. So that's another really good example of self-awareness around circadian rhythms and how it impacts your physiology and comfortability with whatever you're doing.
So this is a tenuous connection at best. I sincerely doubt there's any research around this, but I'd be interested in, a lot of people say you shouldn't look at your phone in the morning because I believe it increases cortisol to a certain extent. I would imagine that has an impact over the course of the day, over the course of your circadian rhythm as well.
Oh, absolutely.
Which I had not considered before.
Yeah, absolutely. You're not the first person to say that. So my postdoc mentor, who I visited last week when I was out in California, what he said, he was that person. He'd wake up every morning, check his email, and get like real frantic about what he had to do in his day. And ever since he made the move from Atlanta, Georgia to Los Angeles, what does he do? He rides his bike out to Marina del Rey every morning from his house, and he looks at the sunset with his wife. It took her a second to like get used to that, but then once she stopped doing that, like checking her work phone immediately, like that's part of their morning routine, and they will both tell you that carries on throughout their day. I feel like I do the same thing, intentionally throughout the day as well, or even before that, like unintentionally. So
it's interesting. I'm not a huge coffee drinker, but if I drink too much coffee in the morning, I'll get like really anxious at night.
Yep, I do too.
And I wonder if that has something to do with, because if I remember correctly, coffee also can increase cortisol. I could be wrong about that one though. But
no, it doesn't. So some of that research is a little ambiguous and needs to be more studied. But to your point, right? Increased coffee, increased alertness. You're already getting that increase in alertness through cortisol. So it is going to be more prone to create anxiety. I get the same thing too. Like there is this weird period between 9:30 and 10 where I just
the scariest
inside.
So something that I'm particularly interested in, especially with this episode, is what are the types of things that can disrupt your circadian rhythm? What can you do that might hinder what you're trying to do from a performance perspective? So we've already talked about at length in the last episode about sleep. We talked earlier about like cell phone use and things along those lines, waking up too early or trying to force yourself into a chronotype that doesn't necessarily fit you. What are some of the other things that maybe are less obvious that people mistake when they're disrupting the rhythm?
So the biggest disruptor is this right here, which is light. So you want to time light appropriately. And quite honestly, natural sunlight is always best. That's why lighting companies now have invested a ton in new technology. A lot of athletic locker rooms in college and professional sports are being outfitted with new lighting technology that mimics sunlight. Same with in the military on subsurface ships. We now have these lighting systems that are meant to mimic sunlight. Bioluminescent or luminescent light is not great for our eye health. It's also not great for our circadian health. And in addition to that, if you are trying to sleep at night, or you're trying to wind down from your day and prepare for sleep, the last thing you want to do, right, is staring at blue light. Like there actually is science and validity behind blue light blocking glasses, those filters we now have on our phones. Because what happens when we're preparing to enter sleep is there's this process called DILMO. This is not a military term. This is a scientific acronym. It's dim light melatonin onset. So just being in the presence of dim light is enough to trigger the production and release of melatonin from your pineal gland to help facilitate sleepiness. And in fact, in the clinical lab, that's how we manipulate sleepiness in our studies when we have people on these non-24-hour days to unmask their circadian rhythms, is we'll simply dim the lights and all of a sudden our research participants are sleepy.
Interesting. So you talked about dim light, and you also talked about blue light. How important is like light brightness versus light like effective color in those studies? Like, is it worse to like say it's red light or like a warm light, but it's very bright versus a blue light that is relatively dim? Is there a matrix associated with that? Great
question, because I think that's one thing that's not talked about in media. Like I know people now are pretty well aware that sunlight and light is alertness promoting, and dim light is not alertness promoting, but spectrum of color matters. So first off, the mammalian circadian clock, this is true in animals and mice and rats, hamsters that I used to study, and in humans, that the mammalian circadian clock is insensitive to red light. So when we would do our sleep deprivation studies, where I would literally sit in a dark room for 6 hours and do small animal brain surgeries to then disrupt the circadian rhythms of these mice, I was always doing it under red light. So part of the reason why I think my nighttime vision without using night vision goggles is really good, because of truly spending years in the dark, watching animals trying to fall asleep or just doing these like small animal brain surgeries. Bright light though, so high energy blue light, like we learn about in physics class, that has a lot of energy, that is disruptive to sleep. So that's the light we're talking about. And that's why things like blue light blocking glasses exist and whatnot.
So it's more a function of energy, right? So like dim, I'm not a physicist, but dim blue light can have as more energy or equal energy to brighter, higher wavelengths or lower wavelengths.
Yeah. So higher wavelengths. That's right.
Perfect. Okay.
Our high school physics teacher will correct us after the episode, Mr. Land.
It's fine.
I don't know why I remember my high school physics teacher's
mine
name.
Was Dr. Moore.
Dr. Moore.
And there you go. Hey, you always remember like a couple teachers. You know?
Yeah, exactly.
So what are some of the other disruptors of circadian rhythm? I know you've done a ton of research into particularly drugs and these types of things. Let's dive into drugs, but also if there are any other things that are big ones we should watch out for.
Yeah. So believe it or not, exercise, right? I worked with actually the world's expert in non-photic disruptors to circadian rhythms. So I worked with this guy. His name's Dr. David Glass.
And non-photic is just non-light, correct?
Non-light, right? Yeah. So photic light, non-photic light, non-light. So Dr. Dave Glass, he was a scientist at Kent State University. He really discovered how animals are sensitive and responsive to non-photic cues, largely social interaction and exercise, and how the components of exercise can either entrain circadian rhythms under some circumstances, but in most cases disrupt circadian rhythms. So for example, me being a vampire, essentially, me working out in the morning, because I don't work out in the morning. Like after we do this podcast, I'm going to go work out in the gym because that's when I'm, peak for performance. If I worked out in the morning today, though, like that would disrupt my circadian rhythm because my body is not conditioned nor primed or truly has never been ready to perform in the morning. So those are the two primary non-photic disruptors. Now, food is another one too. Like we know because of these food entrainable oscillators and like rewards, right? Drugs, for example, those can disrupt circadian rhythms as well. And that's actually what I spent a lot of my graduate school doing.
Interesting. I'd love to talk about that a little bit more. Like what are the impact of drugs, like particularly different types of drugs? You have stimulants, you have depressants, you have alcohol, which is also a depressant. But yeah. I'm wondering if there was anything you observed. On the other side of that, it also seems like a lot of these things that are not drugs that disrupt your circadian rhythm can be used to adjust it to a new time zone or something along those lines. Yeah,
so that's exactly what we do. So I have done some pro bono consulting for professional, collegiate, and Olympic teams over the years, and those are exactly the strategies we use. We use a combination of light as well as timing of exercise, timing of meals to effectively adjust somebody's clock as quickly as possible. I feel like I've become a master of the profession myself, just with all the travel I do for work here. So, I try to practice what I preach to in terms of trying to use these components to adjust my clock quickly as well.
And so it's those core three, and then I assume you might use like a melatonin or you use like caffeine or something along those lines as well.
Yeah. So caffeine, but again, being mindful of how close to bedtime, and then melatonin for sure. That's something I always travel with and dose with appropriately.
So when I was talking to Dr. Grandner, he was saying that like the maximum efficacious dose of melatonin is around 5 milligrams.
Yes, at most.
Correctly. Okay.
Some people would take, there are products out there. I went to a drugstore the other day. They have these little gummy cubes of melatonin that had 20 milligrams in it.
Jeez.
Yeah.
And so he was suggesting to me, and I want to make sure I remember correctly. This is good for me too, for memorization. But basically if you take more than that, it just continues to push your sleep cycle later.
Yep.
Rather than making you more tired. It just.
Yep, exactly. Okay. And I mean, it can also have the opposite effect too. It's the same thing with alcohol. Alcohol in small doses can actually behave as a stimulant, and then in large doses, it truly behaves as a depressant. It's the same thing with other classes of drugs too.
Well, I think it's important to talk about drugs too, because a lot of athletes in their downtime, a lot of successful people in their downtime are using alcohol, they're using recreational drugs, whatever it might be, to unwind. Mm-hmm. And I think they think it only has a one-day effect, but it could have a longer-term effect. Can you talk about what the long-term implications of some of these different things, different substances?
Yeah. So when it comes to sleep, for example, so alcohol is a big one I studied. So in graduate school, basically we had money from the National Institutes of Drug Abuse and then the National Institutes of Alcohol Abuse to study the impacts of alcohol, cocaine, fentanyl, different recreational drugs on sleep and circadian rhythms and animal models. So pretty much we've done studies in all these areas. We know with alcohol in particular, that it dampens restorative sleep. So it dampens entry into deep non-REM sleep, which is the state of sleep where you have testosterone release, you have growth hormone release. And it also dampens time spent in REM sleep, which is also restorative, especially for cognitive functioning. So you have that recovery piece right there lost. The most important thing we found with alcohol, and we really investigated this at like a genetic and a neurochemical level, is that it disrupts the ability of the retina and the circadian clock to effectively recognize light in your environment. So essentially, we would dose our animals at really high doses of alcohol. And then we would try to what we call phase shift them, which is essentially like put them on a jet lag protocol. And they could not adjust to jet lag because the alcohol blocked the photic signal from reaching the circadian clock.
That is fascinating. I mean,
Yeah.
I think of really big, like high level implications associated with athletes that are traveling in particular. If you're on the plane and you're drinking, it's like, oh, it's our time to relax in between games or something along those lines. Probably not happening at like the NBA level very consistently.
Yeah.
But at some other levels.
Well, you would be surprised. I mean, not to name like teams, but I have done consulting with other professional teams, and in particular, the sport of hockey. Like the sport is known for like essentially athletes taking stimulants to focus and increase vigilance with their late night games, and a lot of times they'll take they'll take sleep hypnotics, so prescribed sleep aids, or combine that with alcohol in order to like wind down, because the fact is they leave the locker room at 2 a.m., 3 a.m. They're on a high, either it's from a win or a loss, and they're trying to get to sleep, and they'll use alcohol to get themselves there. So we've, through the help of just understanding and getting them to understand the impact of alcohol, not just on their ability to wind down and effectively go to sleep, but the long-term implications for testosterone release, growth hormone release, and ultimately recovery and injury. Yeah, we've, changed the holistic culture of some of these teams.
Well, there's also the comorbidity with a lot of the mental health challenges, like major depressive disorder, anxiety,
absolutely.
things along those lines. I mean, that's something we've covered pretty extensively in the Michael Phelps story, is that some of those things absolutely can happen without alcohol or any recreational drugs.
Yeah.
But especially with alcohol, essentially all of them are compounded. And also with lack of sleep, all of these things are compounded.
Yeah. Plus TBIs, right? That's even, it's bad enough in like a sport like, what Michael Phelps, like swimming, but it's even worse in football and hockey and lacrosse and soccer, where you have a lot of head impact.
Well, I think that's a perfect time to talk about what's going on with the college football merger. Mm-hmm. It seems like a lot of these are creating a perfect storm for not great outcomes with these college athletes. I mean, just from what we described there. I mean, frankly, I'm sure a lot of these players are going out on the weekend. Right?
Oh yeah, they're in college, right? I was a college athlete too.
There's nothing necessarily wrong with that. But they're also playing football, which has high TBI likelihood, and their circadian rhythms are now changing in terms of their travel schedule and things along those lines. I'd love to hear your take about what the implications are, especially with the new shuffle of the
I mean, I don't think we'll see many things immediately. This really is the first season for it. Like there's little games here and there. Last season, I actually helped Michigan State pro bono with their switch when they played a game out at University of Washington. But I think after this season, I hope that sports analytics, the sports med staff really start to look at these relationships. So we wrote a white paper a few months ago. It got published in our flagship journal called the Journal of Biological Rhythms Research. So basically a group of sleep circadian biologists, to include Dr. Mary Carskadden, who I work for. It was our essentially call to action. And the point of it was to give it to all these commissioners of the Big Ten and the Pac-12 to just have them be situationally aware of the fact that there were likely to be consequences on academic performance, athletic performance, and not just that, but risk for injury and risk for concussion. Years and years ago, so my cousin is actually an orthopedic surgeon. He's worked with the Pittsburgh Steelers. He's now with the Cleveland Browns. He and I actually published a paper where we looked at publicly available NFL data, and we found that there are relationships with time that a game starts based on the team's biological time and injuries. We found essentially teams who are playing in their true biological afternoon, understanding most of these teams don't have the opportunity to adjust to a new time zone are the most likely to get injured. And if you look across the season, it's no surprise that West Coast teams have about 5 times less injury throughout the season than East Coast teams.
Wow.
Because, and this isn't something that like my cousin Justin and I found. We weren't the first. Actually, the group at Stanford, like the true godfathers of sleep medicine, found this in the 90s. And then we essentially replicated the finding years ago. We have some data now to look at concussions in a similar realm. And we're already seeing trends in terms of there's likely going to be more concussions in the biological afternoon than there is in the biological evening. But I really think that's where, this is a long-winded answer, but that's really where you're going to see I think the greatest impact is injury, whether it's TBI or skeletal muscle.
And I think that it's also, from our perspective on this podcast, what we're trying to do is provide as much information to an athlete or a coach. Maybe for them, if you're not on a college team where kind of beholden to the schedule of the organization, or even if you are, maybe some of these protocols will help, but maybe just moving and going a day early somewhere and just adjusting a little bit longer.
So there's really no easy win, right? Because then you're dipping into the athletic schedule. I always wonder, not to knock certain schools, but like Stanford, for example, Berkeley, right? Known to have a very high academic load in addition to high demanding Division I level sport schedule. What their athletes are doing, because I remember many times when I was track and field at Brown, like we just traveled East Coast. We did have a meet out at Stanford every year, but that was once a year. There's plenty of times where I've had to take quizzes, I've had to take finals, I've had to take midterm exams in a business center of a hotel. So it does make me wonder what these universities are doing to preserve and protect the, academic performance and academic record of these students too, who, at the end of the day, probably about 5% of them will be professional athletes. The rest of them will want to go to med school, to law school, some professional school, do something high performing in society that's not anything to do with sports.
Yeah, I wonder if that would hurt their recruiting in the longer term. If hoping people are more knowledgeable about this in the future.
I've already heard it has.
Yeah,
because I've already, honestly, I in the New York Times article, I said that. So I was fortunate. I got recruited by all the Ivies, and then I also got recruited by Stanford too. Honestly, I would have not gone to Stanford. Like for me, it was Brown, Harvard, Cornell. I chose Brown. But Stanford, I would have not considered going to Stanford because of this merge. So I definitely think, and I've heard from others, it's affected their recruiting as well.
Well, especially if you're going to a school like Stanford, as you mentioned before, you probably care about your academics. And if there's something that would hinder you from being as good a student as you could be and as good an athlete as you could be, I feel like that's a pretty tough sell in the longer term.
Yep.
The last thing related to circadian rhythm I would really like to get more information on is how it's related to inflammation. I would imagine that there is probably a link between these things, but this is something I know absolutely nothing about.
Yeah, no, I'm happy to talk about it. I know in our pre-brief, I didn't give you all my research, but I did do a little bit of research on the relationship between circadian rhythms and inflammatory pathways in an animal model. So when I was a postdoc at Morehouse School of Medicine in Atlanta, Georgia, I was working with a scientist who's still there. His name's Dr. Alec Davidson. Essentially, he did a study where he progressively phase shifted or shifted a mouse's schedule by 6 hours in a way that was super stressful. And when they injected them with a substance that essentially made them sick and have a very massive inflammatory response, the animals that were phase shifted died. Whereas those who were not phase shifted did not die. So we took that model and we tried to look at the impact of sleep. So essentially what we did was, again, we made these mice very sick and caused a large inflammatory response. And then we either phase shifted them or we just sleep deprived them. And we found that the rate of mortality, so death in mice that had been phase shifted, which was much greater in mice who had been sleep deprived to a similar amount. So
interesting. Very, very concerning.
Yeah.
What are the practical implications? I mean, obviously it's hard to extrapolate between animal and human, but
you're right.
What would you say the implications maybe associated with like an athlete in that domain might be?
We also did, downstream sequencing of different inflammatory pathways and the genetic molecular expression of these pathways too. And we did find in those animals who were phase shifted versus sleep deprived, those who were phase shifted had increased inflammatory markers. So when it looked at the underlying reasons why they had increased mortality, it was because of the activation of these pro-inflammatory pathways that you truly didn't see in mice who were just strictly sleep deprived.
Interesting. So it might be that like we don't want to be sleep deprived or
right.
phase shifted.
Yeah,
but,
exactly. But if you had to pick the two, like if you are at home and say you are on during the work week, right? It is better to be sleep deprived during the work week than it is to do what I do sometimes, which is travel across the country in a work week. I have my own ways to how I think. I manage my means of not getting sick. Some of it might be placebo, but I'm very well aware because of this research I was doing years and years ago, the implications that all of that travel can have on sickness. And honestly, that's what I think you're going to see the most, relating it back to the Big Ten Pac-12 merge. I think at the end of the season, if you had the sports med staff or you just had physicians attached to the teams look at how often athletes were getting sick or were on the bound of getting sick or, getting prescribed antibiotics or something, you're probably going to see a lot more of it.
Well, anecdotally, I moved from Hawaii to Austin, right? And I travel probably twice a month for work, for podcasts, for different things.
Yeah, that's rough.
And when I was doing that for about 2 years, it's the most sick I've ever been in my entire life.
Yep. Oh,
and
absolutely.
Then now I moved to Austin. I don't have to wake up at, I don't have to take these crazy flights anymore.
Yeah.
I don't have overnight flights anymore, which is incredible.
Oh, I don't do that either.
It's unreal.
Yeah, I've been to the West Coast twice this month for work, and I refuse to do overnights anymore. I used to do it because I have the whole day, but now I know better because I don't want to get sick. Like, to me, getting sick now, it's such a dip in my work week.
Yeah, well, it has compounding effects in terms of, like, if you're sick, you can't, for example, exercise train. Or you can't do a lot of these other things that are part of the flywheel of what we like to do every day.
Yeah,
which is very difficult and can have some stalling some stalling after effects.
Yep. My wife will tell you that when I am sick, you're right. My biggest complaint is because I still do CrossFit and I can't breathe. And of course, right, like when you have bronchitis or some upper respiratory issue, you can't breathe. And she hates when I complain about it because it's still relatively better than most people, but still, I notice a difference.
Oh yeah, of course. Well, I think that's also really difficult with high level athletes in general, is when you're practicing, when you're trying to compete, if you're still able to do it, but you're not hitting the numbers you usually do, you're not seeing the performance you usually do, psychologically that has implications as well.
Oh, absolutely.
And if you're operating when you're traveling, or any of these athletes at 80, 60, 70, whatever percent it is, that plays a psychological toll on them too.
Oh yeah. Well, even just having a fever, right? Increase in core body temperature in order to naturally fight infection. That has an impact on cognitive performance. We know that it has a huge impact on reaction time.
Yeah. Something that never ceases to enthrall me is just the compounding effects of a lot of these types of things. I mean, that is by definition what the podcast is about. Yeah. The exponential athlete is like, you get compounding returns, but you can also get compounding negative returns. Yeah. You get things that go the other direction. And I think the focus here is we always want to be compounding the things that are positive for us and avoiding the things that negatively compound or create negative feedback loops in general. So shifting gears just a little bit, I know you've cut your teeth in behavioral genetics research, and I was wondering if you could explain to me at a high level what that is
Sure.
And maybe what some of the implications are as it relates to the military, but also as it relates to sports.
Yeah. So behavioral genetics is simply linking a unique genotype to what we call a phenotype, which is basically some unique attribute or behavior in an organism. So perfect example, right? There are people who are morning people. There are people who are evening people. Morning people, they have a particular, it's called a single nucleotide polymorphism. It's basically a naturally occurring mutation in your genetic code and some of their circadian clockwork. Same with evening people. They have a single nucleotide polymorphism and another gene associated with the circadian clock. But you see this across the spectrum. One of my favorite books, and actually it was an inspiration for my own book, Meathead, Unraveling the Athletic Brain, is this book called The Sports Gene, where it follows different populations of sprinters and hyperendurance athletes and looks at their skeletal muscle architecture as well as their physiology to explain regional differences as to why, it's not a surprise, most of the fastest sprinters in the world, whether they're here in the US or elsewhere in the world, come from this one small town in Jamaica. Because at the time, for having those regional differences in this gene, it conferred into some aspect of survival. Just like we find a lot of good cross-country skiers, a lot of hyper-endurance athletes come from Scandinavia because they have a unique genetic polymorphism linked to hemoglobin and the ability of oxygen to effectively bind to hemoglobin and to increase oxygenation within their blood. So I like to think, so I've looked at this in many capacities in the realm of sleep deprivation in mouse models and then in humans. That's a lot of what I've done for the military when I was stationed at Walter Reed, is we essentially would sleep deprive people for extended periods of time, anywhere from 48 to 64 hours. And we would look at the rate of decline in their cognitive performance, also their pain tolerance, their mood. And we actually identified unique single nucleotide polymorphisms in people who are resilient or not resilient to sleep deprivation naturally. No drugs involved, just naturally. What's really cool is we've actually taken this research out to the field. So we actually did a study with the Ranger Regiment. And the same exact polymorphisms we found in the lab that promoted resiliency to sleep deprivation, we found that out in the field with the Ranger Regiment as well.
I would assume they have a far higher population with that.
Oh, absolutely. Yeah. But it goes with the course. And, you know, a lot of people don't like to hear this, but assessment and selection, yes, it's about hard work. But to me, it's also about finding good genetics. Again, it's controversial, but like Ranger School, I truly think the benefit of Ranger School is you're trying to find people who are resilient to sleep deprivation. Because at the end of the day, that's what you want from a safety perspective. You want people who are able to endure and still perform better under sleep deprivation than others. It's the same thing within our community too. You want those people who are resilient to stress, resilient to pain, resilient to sleep deprivation. And yes, some of that is trainable, but a large part of it is genetic. So that's like behavioral genetics in a nutshell.
Yeah. Well, I mean, that's no different to how we look at sports. I mean, you take a swimmer or a basketball player, there's some basic level of physical size that they need. I mean, this is just like a different attribute that is less clearly physical.
Mm-hmm. Yep.
So would the genes expressed under stress also fall into the behavioral genetics category?
Oh, absolutely. So that's, you know, if you think about sleep deprivation, some of the other military research labs have done this with other stress, like tolerance to environmental stress, cold tolerance, heat tolerance, just stress of high cognitive load. We now have single nucleotide polymorphisms associated with being able to handle those stressful environments more so than others.
Interesting.
Yep.
The more we have this conversation, the more I am realizing I would absolutely not be cut out to be an Army Ranger.
Well, it's funny you say that because so I volunteer and coach twice a year at this camp for Olympic development gymnasts. And then we actually bring in CrossFitters who are trying to learn foundational skills in CrossFit. And the camp is put on by my dear friend, Dave Durrani. And Dave competed in the 2008 Olympics, which is, the same Olympics I thought I could make. And we have a team of gymnasts. We have 2008 Olympians from rowing. We have 2008 Olympians from Olympic weightlifting who help run this camp. And it's really funny when you get us all in a row, because all of us gymnasts, we look like gymnasts. You see the rowers, they're all 6'4" and taller, to include the women. And then you see the Olympic weightlifters, they're somewhere in between the gymnasts and the rowers. So it is, you can really pick out a, Olympic level swimmer from a non-Olympic level swimmer just from how they look, right?
Yeah. Well, that's something I haven't thought about or talked about on the podcast necessarily, is self-selecting for sports that are catered to you.
Right.
I mean, physically, one of the reasons I really pursued golf is because I saw that as the most equitable in terms of being able to have hard work leveraged into performance.
Yeah.
I mean, physically, basketball is way out.
Well, unless you're Muggsy Bones, right?
Yeah.
But there's some one Muggsy Bones,
exactly.
right?
And also, proportionally, to that point, he was all legs. I have unbelievably short legs and a really long torso.
Mm-hmm.
So it's the opposite of what made him able to jump.
That's why you're good at golf, though, right?
Yeah.
You need that leverage.
I actually learned recently, I was born, and I think it's not uncommon in Asian people, but with my lower two vertebrae fused. Mm-hmm. And that actually probably hurt me developmentally in golf, but that wasn't something I knew until later. I mean, I don't know if I would have done anything different.
Right.
But the idea is that actually rotational hypermobility is something that is very, very common across high level golfers. Mm-hmm. And that's something I frankly didn't have.
Yeah.
So it's I had this hidden impediment that I didn't even know about. And sometimes just awareness and knowing your body and getting diagnostics done can help you evaluate those things.
Yep.
Fortunately, I have no impediments associated with being as effective a podcaster as possible. So,
well, it's funny you say that. So I actually have very long femurs for my height. And I've always wondered why, I can lift heavy, but my squat numbers are not great. And it's because I have really long femurs. So I have to get a lot lower, and then I have to come up a lot more in order to have a full rep. But one thing that has helped me, and I didn't realize this until college when I started doing the heptathlon, and I still compete now in the heptathlon as a master's. I know this is kind of gross, but I'm double jointed. You can't really see it, but I'm significantly double jointed, which is great for throwing a javelin, right? Because you put your arm in a really weird position, and a lot of people get Tommy John. I feel like I'm at low risk for Tommy John syndrome because my elbow is just naturally hyperextended.
Interesting.
So probably benefited me in pole vault too. Honestly, that's probably why I could get more bend out of the pole and, get underneath and inverted a lot higher.
So it's been some time since 2008. I'm interested. What was the difference maker between you not making the Olympic team and you making the Olympic team? In retrospect, was it just a purely physical thing, or was there something that you felt like you left on the table?
It's both that, and I thought I can get a PhD in neuroscience at the same time. So I came to basically pole vaulting late. I was actually one of the first female pole vaulters in the state of Ohio. Essentially, I had a track and field coach who she knew pole vault was going to be contested as a girls' event. And so she asked me and the other gymnasts to basically be pole vaulters. Our high school didn't have a pole vault pit, so I used to have to travel to a nearby high school, which actually had the only pole vault pit in the county. And then once a month, she would drive me to Ohio State. So I was fortunate in that I learned to pole vault from the Ohio State coach. But that turned out to be true for most of the girls in Ohio that year. And so it's no surprise that all 8 of us who placed at the state tournament all had the same coach, Dave Garcia. So in college, I did really well. But I also felt like I was an athlete who kept getting better and better. So my junior year, I did great. Senior year, I did great. I didn't make it to NCAAs that year, but I made it to ECACs, and I did well at the Ivy League championship. So I just felt mentally like I still had more to grow in the sport. So when it came time for graduate school, this is a true story. Like I was fortunate in that I got to work with Dave Glass, who was an expert in the non-photic regulation of circadian rhythms. But the real reason I went to Kent State is because I knew one of the best heptathlete and pole vault coaches in the country. Bill Lawson was there. And then also nearby was this guy, he's still there, Dennis Mitchell at the University of Akron, who also helped me learn how to pole vault when I was in high school as well, because I grew up in Northeast Ohio. But I realized, like, honestly, within like the first semester of grad school, like, oh, even if like Olympic trials were coming up and I could prepare, like, there's no way I could have done both. And I had to like make a hard choice, but I was like, obviously, I was fortunate. I was valedictorian of my high school, went to an Ivy League, like education and scholarship was important to me. I wanted to be a neuroscientist. So I just gave up that dream, focused on coaching, and then focused on neuroscience. But I do think physically, I do have like the physiological attributes to be a good pole vaulter. And I still, like I said, I still pole vault today. Like at 40, I'm the reigning gay Olympic. So I compete in the gay Olympics every 4 years. So I'm the reigning 2-time gold medalist in the pole vault for there. I've competed in master events throughout the country. So I still feel like I'm, able to do what I can in the sport because of my unique physiology.
Absolutely. And, I think that something we see with a lot of athletes is there's trade-offs, there's sacrifice, and like, the trade-off, I think you made frankly the right one because you're incredible at what you do now. But inevitably there was like a choice you had to make, and like everyone has to make choices like that. And sometimes the choice is, I'm going to have like a beer tonight and I'm not going to think about the consequences of the performance. And sometimes it's like a very clear pivotal one where it's like, man, they have these two really good options that are both like net positive return on investment.
Yeah.
And you just have to choose one that is going to have the best decision that you can have with limited information. Right.
Yeah. Yeah. Well, the irony is so later on in life, like, cause truly my two goals in life was to be a professional athlete or an astronaut. Like, as you know, I'm still chasing the dream to be an astronaut. But I did get to be a professional athlete for the Army because years ago, the Army started a CrossFit team where essentially we had similar structure as the world-class athlete program at Fort Carson at the Olympic Training Center. We were stationed at Fort Knox, Kentucky, but like for legitimately 2.5 years in the Army, I was a professional athlete and I trained and I competed around the country. Unfortunately, not the world because it's COVID. So, but I did ultimately reach that goal of being a professional athlete and not trying to do both at once because I was doing that during my postdoc. I was competing in the CrossFit Games and I was a postdoc, but I also think I was still in my 20s at the time. So I could do both, but there's no way in my 30s I could do both.
From your research and from everything what was the biggest crossover for you for sports? I mean, is it just like, do you view it in the exact same way, like as systematically and stuff? Or is it something that there's a little more secret sauce? Because like as an academic looking at sports, it's very different than actually playing them. And you have the brain for both kind of.
Yeah. I mean, I think the biggest thing is like dopamine, right? And motivation. Like when you just look at that, like what drives you to get up in the morning and do the same thing? Like eventually it becomes routine, right? I feel like training and exercise have been embedded into my circadian rhythm. It's the same thing with being an academic. It's a long grind, right? It's not a 9-to-5 job. You constantly have to be thinking about scientific concepts and how you're going to solve them and how you apply the world to them. That requires motivation. So having a surplus of dopamine sure helps. I think I probably have a surplus of dopamine compared to most people. And I'm sure some of that is like genetic in nature too. But motivation is probably the biggest one.
Interesting. And is there something that is obviously like dopamine, like from a chemical side, important? Are there things that like structurally you think also give you that like an extra push?
I mean, because motivation is hard, but we talk a lot about purpose. We talk a lot about goals. Are there mechanisms like that you use as well?
Yeah, I mean, I think, genetically, I come from a family of very good athletes as well. So I think that's also part of it. Like I have the body type of what it takes to be a professional athlete or close to one. So both of my uncles were professional boxers. I have a great uncle who's Slaby, who was a linebacker. Brian Hoyer is a distant relative. So I have like a history of athletes in my family too. And it's actually most of my cousins and I were college athletes, either, D1 through D3. My brother was a D3 soccer player, tennis player. So that definitely helps as well.
Amazing. So a couple things came up in my research that didn't neatly fall into categories. I really wanted your take. I think you understand these things very well. Something I kept seeing, particularly in swimming, that I'd never seen in any other sport that I've studied, was consistent testing of lactic acid.
Oh yes, that's a big one. Thank you for bringing that up because we did talk about that.
I'm really interested in your take on that.
Yeah, so lactic acid is really a rate limiting factor for both aerobic and anaerobic sports. So essentially anything greater than 100 meters, right? Now, granted, I'm actually really good at the 100 too. Like I was pretty fast in high school, and again, the Gay Olympics, I'm reigning 2-time gold medalist in the 100 meters. Like creatine, that's all creatine, right? None of that's really lactic acid because your body doesn't have time to build that up. But one of the unique things about high intensity sports is it's not about VO2 max, it's about your ability to clear lactate quickly. And you brought up the work with Michael Phelps in terms of like, that's how he was trained. And I was actually part of a study with elite CrossFitters back in Georgia. My buddy Yuri Fieto, he was doing a study when he was at Kennesaw State, where he tried to understand the physiology of what made elite CrossFitters elite. And so we did those horrible Wingate tests with VO2 max on the bike and the running VO2 max, where you increase the treadmill grade. And every 30 seconds, he was pricking our fingers to pull lactate. And then we did the horrible CrossFit workout, Fran, the thrusters, pull-up workout. And we did it with, I forget what it's called, but basically it's looking at the output of CO2 and uptake of oxygen as a measure of VO2 max. And our VO2 maxes were average, but what was really good was our ability to clear lactate. And we had the right metabolic metabolites to effectively clear lactate. And so it kind of made sense why I became good at CrossFit after all those years of gymnastics, all those years of pole vault. I was a 400-meter hurdler in college too. Like why I was good at those, 400-meter or below activities is because I had this like uncanny ability to clear lactate quickly.
And so when I was reading the research in like the Phelps study, it was a while ago, and it was ambiguous if it was the actual lactate in the muscles that was impeding performance or if that was a byproduct of something else that was causing a performance breakdown. Has there been any like reconcile of that, or does it not really matter technically?
That I don't know. I mean, again, like your study was looking at blood lactate. So obviously this is lactate that is being produced by the muscle and then traveling through the bloodstream. But what I will say from like standpoint of mitigation. So we actually, when I was on the CrossFit team, we were doing a small study with this company at the time who had some DoD funding to get their products into the DoD space. And they had this lotion called sodium bicarbonate lotion that we were talking about because sodium bicarbonate acts as a buffer for lactate. Lactate is a metabolic byproduct that is acidic in nature. So what's that mean? It's going to lower your cellular pH. And so sodium bicarbonate, a lot of cyclists take it, for example, because it helps buffer that lactate that they build over time as they're climbing hills and mountains and stuff. And so we actually use that And when we paired that with our wearable data, we actually found that we had improved recovery during the most important, crucial qualifying part of our season, which was the CrossFit Open. And, to this day, it's funny, my teammates, they always refer to it as my janky ass lotion, but like, I love that lotion and I still use it today when I compete.
Yeah. I mean, it's interesting that it's a topical. So I've heard about it. I mean, so for those listening, sodium bicarbonate is effectively baking soda. But it has pretty bad digestive gastrointestinal distress if you're just like eating baking soda.
Yeah.
So it's interesting that you can have a topical. I've seen some like goo products and things like that claim to mitigate some of the effects, but they look really gross.
Yeah. So what's unique is the reason why this company got a lot of DoD research and development dollars is because they spent millions of dollars trying to make a transdermal lotion. It's actually really hard to make things that effectively cross the skin barrier. And so they were able to, I don't know the exact like biochemistry, but engineer it in a way where it was transdermal and it could actually buffer the lactate that was being released into the bloodstream.
Interesting. I will I'll get more info on that from you and link it in the show notes as well. So it's been, I think you wrote your book in 2014.
Yeah, it's been like over 10 years now.
It's been a while. A lot happens in 10 years.
Yeah.
And I highly recommend everyone read your book. I read it. It was very, very informative. On the other hand, there's a lot that has, a lot of science has happened since then.
Yeah.
So I was wondering if there's any maybe like key scientific advancements in that same sports performance space outside of what we've already talked about that you're really excited. And if you were to hypothetically write another book or add to this book that you would consider putting in.
Yeah. No, great question. So I think the overall messaging would stay the same. I would just have a lot more definitive support for the concepts I outlined in that book. So really the inspiration for writing that book came to me in 2012. And it was just one day. So again, I was fortunate. I went to Ivy League for undergrad and the athletes were hated I don't know what it was like at other Ivies, but at Brown, the athletes were hated. Like we were called dumb and dumb jocks, and there was such a stigma. And people would always say like, oh, well, the only reason you got into Brown is because you were good at sports. And so like, it was irritating, but at the same time, like we used to throw it back at them and call them NARPs, which stands for normal, average, regular people. So anyway, despite that like turf war, I always found it interesting that after college, it was my friends, because I was friends with both athletes and NARPs. I love my college friends. I always found that those of us who played sports went on to do high performing jobs, either went to law school, medical school, got a PhD, went on to run companies. Now some of my friends are running Wall Street essentially. And I started just looking into, there was an article at the time that came out by a scientific journalist named Carl Zimmer, highlighting some of the CEOs of major corporations like Bank of America, show the Shanahan brothers, they were athletes at Brown, and other CEOs of GM and other major Forbes 500 corporations were also athletes in college. And it's like, there must be something to the neuroplasticity and the extension of that neuroplasticity you build in sports and how that translates to success later in life. So I had this idea, and at the time I was teaching an undergraduate neuroscience course at Morehouse College. And it just was like a perfect storm. Like I had this aha moment while riding the bus home from work one day. And I was like, I'm going to write a textbook on the neuroscience of athleticism that follows along with like the neuroscience curriculum that I taught at Morehouse College. And so that's why you have that like, eventual or gradual progression in explaining how nerve cell communication works and how that relates to athletes. And then you look at what separates an amateur athlete from an elite athlete. And then towards the end, when you get into more nuanced things such as sleep and circadian rhythms, and then again, performance enhancing drugs and why they work, and all of that. So I do think now, like really what I could add is won more sports in this area. Because if you remember at the time, really the only sports I had to pull from were like random athletic sport or Olympic sports, like badminton and table tennis and tennis. A lot of hand-eye coordination sports, not a lot of swimming, not a lot of baseball, not a lot of football. Honestly, I feel like the book would have been more difficult to write today because
there's actually
I want to know what to
information
focus. You know what I mean? Like I could have a whole chapter on TBI. And actually what's interesting is if you remember, I don't really talk a lot about TBI and concussions in that book because that was 2012, 2011 when I wrote it. So that was even before the NFL adopted the change in tackling rules. Long story short, yes, I think I'd have more foundational support for the types of neuroplasticity and, evidence for choking and muscle memory. And, the ability to take risks without actually engaging your frontal cortex appropriately. Like I have more evidence for that, but I don't think the research would change.
So I'm really grateful to you for writing that book because obviously I read it after I started this podcast, but I think it's a great foundation for what we're trying to do here. I mean, for better or for worse, there isn't like a ton of source material, but I look at this as an extension of like, hey, how do we have a living, breathing document or a living, breathing lexicon to essentially provide more examples, to do these interviews, to have these conversations, and to continue to gather that research. And obviously people are doing it in the scientific sphere, but I think there's also something to be said about doing it in the and consolidating that information and making it accessible to people as possible. So I think that's like a really elegant full circle way that we've come together.
Yeah, no, absolutely. So cool. And I think the coolest part about writing this book, so one of my best friends, and it's actually how I met my wife, we started a professional research society called the it used to be called the Society for Neurosports. But then I think too many people thought we were like a professional research study for our Society for Esports. So we changed it now to Sports Neuroscience, but it's really that book and this whole community of people I'm now connected to include how I met my wife through the Society for Sports Neuroscience. So like this research is growing and growing, and our conference is in February, and I'm so excited because like our human performance team is going to go out there to just learn.
I'd love to come if
exactly.
Possible,
absolutely. I'll send you an invite because, it's a bridge of all the academics, right? It's a nonprofit bridge of all the academics in exercise physiology and neuroscience, and bringing us all together and just, doing this synergistic research.
Amazing. Allison, this was such a great conversation. This is fascinating to me. I learned a tremendous amount. Is there anything that I should have asked that I didn't?
No, I think we're good. Yeah, you definitely have done your research, and I appreciate you not asking these like basic questions about like, how do you get to sleep at night, and what's the best sleep hygiene routine? Not that those aren't important, but like
I also just peppered Dr. Grander with those, so I was like, I'll give
that's fine. That is true. Well, I'm not a clinician, and he is, so like I feel more comfortable in him answering them because
Well, I also think it worked out really well in terms of how you complemented each other, because also he's a clinician, but you have practical experience in sports. In a very different way, and I think that's very exciting for me, and it's also you can tell great stories around it as well.
Yeah, I mean, I think that's what makes our team great. Like he has been my friend now for like, oh my God, like 15, 20 years, because we like our field is super collaborative. And I'm really grateful for that because I try to, take care of him. He tries to take care of me, but bring each other in and cater to our strengths to make, both of our research programs better.
I love that. One more thing. If people wanted to learn more outside of, checking out your book and things along those lines, what's the best place for them to do that? Is it Instagram or something along those lines?
I mean, I don't really use LinkedIn. I'm not looking for a job. I have a job for the next, 12 years, if not more. I have an Instagram, DocJock, DocJockZZZ.
Okay. So. I will link that in the description as well. Allison.
Yeah,
thank
of course.
You so much.
Absolutely.
This was incredible.
Yeah.